Hi, and welcome to question 9 of the Leaving Cert Ordinary Level 2024 Paper 2. As always, if you want a copy of these notes, just send me an email at shanetry@gmail.com. Like and subscribe to get access to more playlists. So we're looking at probability here in the first little bit. Part 1 and 2 are marked together and they have a 10-mark scale. Diarmuid owns an ice cream van. Part A says Diarmuid sells 7 different flavors of ice cream, 4 different toppings, 2 containers, either a tub or a cone or a tub. Now, part 1 says how many different choices are available if you must choose only, and they've highlighted that, only one flavor and one topping and either a cone or tub. Okay. So the interesting thing there is the word and, which they don't really say. Okay. So we have to choose a flavor and a topping and a cone. Okay. Now the word and means multiply, okay, in probability. So once you realize that it's an and situation, you're multiplying your numbers 7 by 4 by 2, and I got an answer of 56. Okay, so it's surprisingly easy once you can read into what the question is saying. Okay, now there is an or here. In probability, or means add. Okay, but there's one choice and one choice, or one choice plus one choice is 2 choices. So it's kind of unnecessary the or there. You might overthink it, which is a problem I often have with probability. Now, part 2 then, which is marked with part 1, says Diarmuid wants to maximize the number of choices available to his customers. For whatever reason, he can only add either an extra flavor or an extra topping. Which should he add? Should he add an extra flavor or an extra topping? Use calculations to put your answer. So it's like a 50-50 chance of getting it right by guessing. Okay. But we don't want to be guessing. We want to work out both extra number of options. The answer is extra topping. Okay. And the reason is if I add flavor, I'm adding a flavor and topping and cone. I had 7 flavors, now I have 8. Okay, so it's still 8 by 4 by 2. I have 64 different options. Okay, if I add a topping, okay, I have an extra flavor and topping and cone. That's the same, still 7 flavors here, but an extra topping, so 7 by 5 by 2 is 70. 70 is bigger than 64, so Diarmuid should add an extra topping in order to increase the number of choices or maximize the number of choices for his customers. Okay, so again, it's kind of an extension to the one. A lot of words, make sure to read these questions multiple times and try not to overthink it. Sometimes they are straightforward, even if there's a bit of grunt work to get to that proof. Now we're in sets here. So part B, part 1 is a 10 marker. It's a B scale, so it's either 4 marks or 10 marks. It's kind of strict in a way. One day, Diarmuid recorded the number of ice cream choices of his first 100 customers. He says here 42 customers bought vanilla, so vanilla flavor was bought by 42 customers. A cone was bought by 37 customers. 45 customers bought neither vanilla nor a cone. The information is shown in the Venn diagram below, and then it says complete the Venn diagram below to show the number of customers in each region. Now, the one thing we know is that there's 100 people in the sample that's given to us on the diagram. We know 45 got neither, okay? Not sure what the hell they got if he only sold ice cream, but whatever. That means 55 people bought something. You think about 100, take away the 45 means there's 55 people in here. Okay. Now, in terms of the answers, okay, what I did first was I went, well, the total number of people who bought a vanilla and a cone, I've added them together and got 79. Now, 79 people bought either one or two things. I'm taking away the 55 who bought something, okay, and I got 24. That means that 24 people bought both. That's why I can put that in the center. And because I know now that it's 24, I can take 42 bought a vanilla cone, 24 of them are accounted for in here. That leaves 18 who just bought a vanilla, sorry, not cone, vanilla flavor on their own, on its own. Then 37 people bought a cone, okay. Take away the 24 that are accounted for in here, leaves me with 13 people just bought a cone on its own. That's not a terribly hard sets question in the scheme of things, but the problem I've always had with sets is I sometimes I just don't, I read it fast and get stuck in. And like maybe one word can change the meaning of it. In this case, it's fairly straightforward. If you're struggling with it, try something. Okay, that something would most likely get you even the 100 taking away the 45 to get 55 would get you the low partial. So at least that if the question is causing a problem. Now then part two, it's only a 5 scale. Okay, a customer is picked at random from the first 100 customers. Find the probability that this customer bought a cone with a flavor other than vanilla. Okay. I had to pause the video there, a bit of an existential crisis in I didn't quite get it in my first reading of it, but we'll read through it again for myself as much as anything else. A customer is picked at random for the first 100 customers. Find the probability that this customer bought a cone with a flavor other than vanilla. Okay. Now, that's this 13 people. So the probability is given by the number of actual things we're talking about divided by the total number of possible things. So 100 is the total number of customers. Okay, only 13 of them brought a cone with a flavor other than vanilla. Again, even as I say it, my brain is kind of struggling to appreciate it. That is a problem with probability. It can be counterintuitive. Okay, it might just be again the moment I'm in. Sometimes with these kind of questions, it's the one thing I'll always look back at an exam and look at it again and just try it fresh. And sometimes you confirm your logic, and sometimes you go, oh, what the hell was I doing in my first thinking? So make sure to check back over your exam paper, but also to check back over specifically the probability. Spend a bit of time on it. Just sometimes, a small thing can be misread or misinterpreted, or whatever. Now, the next question then, part C, is a 10 scale. It says, in general, sales of ice creams increase as weather conditions improve. Diarmuid's typical ice cream sales for different weather conditions are shown in the table below. The table also shows the probability of each weather condition next Sunday. Okay, so lots going on here. So typically he sells on a wet day, 150 euros worth of ice cream. A dry, cold day, 200, but on a dry, warm day, 450. Okay. There's a 30% probability of wet conditions, a 45% probability of dry and cold, and a 25% probability of dry and warm next Sunday. Now, they should all add up to 100. I think so. Remember, probability, this is percentage probability, but probability scores between 0 and 1. 0 is it cannot, will not happen. 1 is it will definitely happen. And probabilities generally score between. Okay, so when we convert that to a percentage by multiplying by 100, we end up with this. So technically that's 0.3, 0.45, 0.25. I'm just dividing them by 100 to get the probability and move away from the percentage probability. Now use the information in the table below to work out the expected value of Diarmuid's ice cream sales next Sunday. There's a hint here, okay? Expected value is a formula. It's not in the maths tables as far as I'm aware, okay? So the expected value is equal to the sum of, now that's sigma, which I appreciate means something different in the modern times, but in maths that means add all, okay? Your data times the probability, okay? So just you're multiplying the 150 times 0.3, because for probability, plus 200 times 45, or 0.45 because it's probability, plus 450 times 0.25 for the probability. So you have to remember that and it would be an error if you were multiplying by 30%, 45%, 25%, because that's a percentage probability, not probability. Once I put that through the calculator, I get 247.5. Okay. Now that's part C. Now part D, we kind of move away from that probability stuff into trigonometry as such. And it says Diarmuid has a logo of an ice cream cone on the side of his van. The logo is made up of a sector of a circle with radius 20. So you see there's a circle here, it's kind of cut off. Okay, that radius is 20, so it's 20 here, okay, and 20 everywhere. Okay, we've lost a bit of it. Okay, and that is given by this 70 and 70, which is 140. Now you could just, if you think it through, that's 360 take away 140 is 220. Yeah, 220. You could add that on there, and it could and most likely will be useful at some stage. Okay. The arc of the sector is labeled S. Okay, so that's the arc. Okay, then the size of the angles are labeled shown, so 70 and 70. Then it says find the size of the angle theta, and hence find the length of the arc S. Give the length in centimeters, correct to 1 decimal place. Okay, so a full circle has 360 degrees. Okay, in this case, the angle theta plus 70 is equal to the 360. Okay, now 70 and 70 is 140. Okay, so I'm just doing a little bit of addition. Then I'm going to get rid of the 140 by taking it away on the left. If I do that on the left, I must do the same thing on the right. And I end up with the angle is equal to 220 degrees. Okay, that's pretty intuitive for a lot of people. Then I need to find out what's the length of the arc. Now the length of a circle is given by 2 pi r, but we're not getting the full length of the circle. We're only getting this little bit of it, which is given by the fraction 220 divided by 360. So even though that looks like a complicated fraction, it could simplify down into a simpler form. But we're going to leave it as it is because the calculator will handle it. And that's multiplied by the actual length, okay, which is 2 pi, by the radius, which is 20. Now, putting that through the calculator, I got 76.79, but the question does state correct to 1 decimal place. The 9 here is what matters. It rounds the number before it up by 1, and I get 76.8, and I include my units, and in this case, the units are centimeters. Now, the next question says, use trigonometry to work out the length of the side labeled L. Give your answer correct to the nearest centimeter. Now, I'm kind of focused in on this triangle here, okay? It's a right angle triangle. Now, you could draw it out separately for yourself, okay? That right angle, this would be the hypotenuse, okay? This is the angle we're focused on, so this is the opposite, and this 20 is the adjacent, okay? So I could use sine, but sine won't work because I don't have the opposite or the hypotenuse, okay? I have two unknowns. Cos won't work. How would it work? Actually, cos would work to find the hypotenuse, okay? I have the angle and the adjacent. I'd find this side, and then maybe you could use Pythagoras to find this side, a bit more complicated. But tan makes more sense. I have the angle, I have the opposite, and I'm looking for the adjacent. Okay, so I write out what the information I have. Okay, then I substitute it into the formula. The angle is 70. The opposite from the angle, I'm just going to stay calling it L because that's what they call it. I'll call whatever I want. And that's divided by the adjacent, which is 20. Now this is fairly straightforward. I'm going to get rid of that 20 by multiplying by 20 on the right-hand side. That's going to cause them to cancel. If I do it to one side, I do it to the other, and I get tan 70 times 20. Now, a lot of people might just move the 20 over. If it's divided on the right, it's multiplied on the left. It's the same thing, it's just a slightly quicker way of doing it. Then I end up with tan 70 times 20 is equal to L. And now you can't multiply the 20 by the 70, even though it kind of looks like that. Tan 70 is a number. We need to look what that is up. The calculator will have it. I don't even need to look it up separately. I can program that in the calculator just like it looks, and I end up with the number 54.94. The question does state it wants it to the nearest centimeter, so the 9 here is what matters. Rounds the number before it up by 1 to get 55. The units are centimeters. Oh, that's it. Right, so let's see on the question 9. As always, try the questions again so you can cement the knowledge. But if you want access to these notes, send an email to shanetry@gmail.com. Like and subscribe to get access to more playlists. Best of luck.